Good morning. I hope you're doing well. This week was an interesting one. I got a fair bit done, lots of little things, and I've got an interesting update regarding the hand. I have put together the Capstan mechanism that we designed last week, and I have a lot of thoughts about this. I've actually, if anyone's been following this on Zulip, I'm guessing there are a couple of people who are on now probably are. You may know that I was. I don't want to give a spoiler. I've got lots of thoughts about this design, and we'll get there when we get there. There's a couple of things I want to get to first, though. So yes, the search for Jugglebot's hand continues. We've got some. There's definitely been major improvements, but there is still some work to be done. But first, we have a couple little things. One is that I have finished the little teensy board mounting spot. So I've cut out its Vero board and soldered it in. And I am really happy with how this looks. I have put together this, I put this on the top of Jugglebot last night, and it all looks very neat, very tidy. I am yet to make the cables that run from the teensy to the O-drive board, and I want to wait on that until I have settled on a complete hand design, because it's possible that these parts may be redesigned, especially that I hope that I don't have to reprint the part that the teensy's on, but I might, and I don't want to cut those cables to the specific length if that length might change. But it's on and it looks very good, and I'm very satisfied with it. The next thing is so you may remember I've been looking at ways to run the communications and power cables from the base of the robot up to this spot on the bottom of the hand, because this O-drive needs communications and power. And someone Peter suggested on Zulip that it's possible to coil cables. And my ideal outcome from this would be a coiled cable, and I just wasn't aware that it's a thing that you can just coil cables, and it's very doable and it works really well. So this cable is extremely stiff normally, it's very hard to bend, and I believe that this is actually a tighter coil than it's a tighter coil than the recommended minimum bend radius for this cable, but it works fine. I've left a link in the description to this stream to link you to the video or the process that I used to do this. I was trying to record it, but the filming gods just didn't want to work in my favor, and all my cameras were either not connecting or out of battery, so I couldn't record the process of me doing this, but I followed the steps in the Hackaday article that I linked. So big thank you to Peter for suggesting this. It's so good. It's so satisfying. The only thing that I will actually mention is that I measured out that the maximum length that this cable would need to be was about 900 millimeters, and I figured I'll just add a bit extra on, because the coiling is going to take a bit, and I don't want it to be fully stretched out to be straight at any point, because that's probably going to stuff up the coiling. So I cut this to around 1.5 meters, and I actually wish that I did a bit more than that. I kind of wish that I went to 1.8 or even 2 meters, just to make sure that the cabling, so that the coiling stays coiled the whole way through. As it is right now, I've put it all together and locked it in its two endpoints and kind of moved the platform around, and it gets to probably that level of stretch, which feels fine. And it's not pulling too hard between my hands, but it would be good if there was a little bit of extra slack in there. So yeah, if you're doing anything similar, leave a lot more extra than you think. Honestly, maybe even double. Yeah, it's pretty cool though. I'm extremely satisfied with that. I could not have hoped for a better outcome from that. So thank you, Peter. Oh no, yeah. Time for an update video. I am in two minds about this, because the time that it will take to make an update video will take away from the actual progress of the project, and everything, it feels extremely close. I think seriously, once this hand design is resolved, which will hopefully be in the next couple of weeks, as soon as that's done, I just need to update the code, and then we should be good to do juggling. And once that juggling is done, then I plan to make a very comprehensive video of like, you may remember me from 7 or 8 months ago when I did the linear actuator videos, and this is where it's come to. So I understand. I can see how it would be tricky to follow exactly what's going on here. And yeah, I don't know. I don't think it's worth it for me to spend the time to do an update video yet. I think my time is better spent progressing and then focusing on the main goal. Yeah. But feel free to ask any questions that you have, just ask and I'm happy to elucidate. Yeah. Yes, the next small thing is that I have done the lid for the bus bar, and I'm super happy with how this has turned out. So over here, I've done a lot of tidying of the cables in here, and following on from my previous learnings with like lids for electronics boxes, this is magnetically coupled onto the ground, so I can very easily just lift this off and then expose the bus bars. So I can come in here and make whatever changes I need to make, and then this just snaps back on. It's a little bit fiddly because some of these CAN cables, they're not exactly the same size as what I had in my CAD, and so they kind of interfere with the box a little bit, but it's pretty good. It's super solid, and I really like the way that it looks. And this is actually making me think that having this sort of hexagon looks really slick, so I'm wondering if I can make like a lid to cover this entire thing, like cover all of the O drives and all of the cabling and everything, having like a hexagon that goes out to like here the whole way around. I think that could look really cool. But anyway, so yeah, this is in here, and this is the power cable that will run up to the platform. And I'm planning on just kind of like coiling this around with that CAN cable that I just showed before, the coiled one, and then run that up. Which is obviously not ideal because you don't really want power cables to run like alongside communications cables. So this is kind of like doing the exact wrong thing by having the power cable go along this. But I don't really see any other way to do it. And to be honest, this cable is so bomber that I don't think that any EMI is going to get through. So I think it should be fine. We'll see. Cool. Yes, very happy with that. And I also, I repaired there was a broken part on the platform that I snapped when I took like the old version of this off, and I just had to fix that, which took a little while, and it made me realize that the friction in some of the universal joints, so if I move this camera up a bit, these joints in here, I described when I put these together, but I put these together in a very silly way, and I think there's more friction in these joints than I would like. So like I had to take one of these whole things off, so I was able to move the rest of it around with just like a couple connections, so I could move it without having to extend any of the legs. And there was a fair bit of friction in there, which I'm not a huge fan of, but I don't really see, I don't know if I can really do anything about that right now, but it's, I don't know, just something that I'm mindful of. Thank you, Anna. Yes, hopefully soon. Hopefully soon. And I appreciate that it's difficult to follow this project right now. And I'm aware that this is a problem. And yeah, we'll see. Soon. Yeah. Cool. Okay, so now let's get into this new hand design, the Capstan design, which does not quite cut the mustard. So to show you what this looks like, I think it's freaking awesome. I love this design. So as I move, let me get this focused on here. As I move the hand up and down, the strings coil and uncoil. Well, they don't really coil, they move along that spool. And this spool is just 3D printed, and then it's got some heat shrink around the outside, and I will get to why the heat shrink is there in a sec. Yeah, so this motion is like very closely keyed to it. So if I slide this back up, so I can make like extremely small movements, and you can see the hand still moves. Like it's very, very tightly coupled. But the problem is that the string can slip against the spool, which is a no-go as far as I'm concerned for this design. So it works okay, but there is not enough friction. And I have tried a couple things. So I've tried just the bare 3D print spool, obviously that's the easiest. I've tried the heat shrink, which is what's on right now. And I've also tried a threaded spool that looked, I don't think this was the exact one, but it's close enough. So there's a spool with this thread in it, and the idea is that the string will sit in those grooves and get grasped a little bit more by those grooves. And that helped. It definitely added a bit more friction. It's probably a little bit more than the heat shrink, but still not a huge amount. So, yeah, let me show you what the problem is with this slipping. So, from what I've shown you so far, it looks great. Like this moves up and down. It's super smooth. It does a really it doesn't add very much inertia at all to just the motor itself. So that aspect is really, really good. Except because the string can slip, you can do wacky things like that, and so the hand will tilt, and it will just stay like this. So as I move it around, the hand will just stay tilted, and this is obviously not ideal. So that's a big problem. This only happens because the string can slip on the spool. I would show you, but it's really hard to kind of focus on it and slip it around at once at the same time. But the end result is that when I tried doing some throw testing, you can see it throws, and that was actually fairly successful. But you can see at the end, the hand is tilted. So you can see like this bit over here ends up on a wacky tilt. And I did a couple of other tests with this, and like in some of them, the motor thought it was at the very end of its travel, but the hand part itself was only like here. So it still had a very long way to go until it was actually the end. And as far as I can tell, this is just because the string is slipping on the spool. So when the spool like cranks up really fast, really hard, the string can't grab onto the spool tight enough, and it just slips, and then, yeah, ruins the throw, essentially. So that's obviously not ideal. That if the string can slip with any reasonable amount of force being applied, that's a no-go. Which is a bit annoying because this Capstan design is really, really good. I've got a couple other thoughts on this, but I will elaborate on those in just a sec. Because I see two paths ahead here. One option is to stick with the Capstan spool design like this and remove the friction, essentially. So where I see this kind of trending to, like I've thought of so many ideas with this, like covering the spool in sandpaper, for example, like a really fine grit sandpaper, or having it like in an adhesive. Like, so I'm imagining like how you can get like adhesive lined heat shrink if I could somehow turn that inside out and then put that on the spool instead so that the sticky side would be pointing outwards, or even just having like double-sided tape. I've thought of lots of ideas, but from what I can tell, the pinnacle of the Capstan idea is using something like synchromesh cable, which for anyone who is unfamiliar is cable that looks like this, where there's like a cable wrapped around the cable. And this is designed to basically be a belt that can go in any direction. So the coiling of the black cable is very precisely structured so that it follows the same pattern again and again and again. So it basically provides an index along. So if you move like one revolution around, if you keyed everything correctly, then you'll be in the exact same spot relative to like the spiral on the outside here. So my thinking is that if we can print or create somehow a spool that has grooves in it that are cut out for the synchromesh, like for the black outer part to sit into, then it shouldn't be able to slip at all. Shouldn't. However, the easiest way for me to produce this would be to 3D print the spool with those grooves cut out into it, but I don't think I'll be able to print on that scale. Particularly because like that synchromesh cable that I just showed you then is the largest size that I have, which I'm not very inclined to use because it's a bit too big to run around the pulleys that I'm using. So I think I might use this smaller size, which is quite a bit smaller. And I really don't think that I'll be able to print grooves that can fit these black bits super precisely, which is a little bit annoying. I'm considering maybe this is an opportunity for me to look into having that spool be like SLS printed, maybe, but we'll see. So the other option if we ignore the Capstan design and say, yeah, that was cool, but it wasn't really ideal, second option would be to fix the strings to the spool. So rather than having two strings where they go up, wrap around the spool, and then back down again, each string would go up and then fix on the spool, and then the next string will go up and fix on the spool, and they would all be fixed here. This is good, but it means that when the spool is spinning, two of those strings will be coiling up on the spool, so more of their length will be coiled on the spool, and the other two will be uncoiling, so less of their length will be on the spool. And that's not so bad, except that it means that we're going to have to deal with the string bunching up on itself again. Like if the string coils up and up and up and up and up, but it coils too much, and if we want to coil too much material onto that spool at any one time, it risks bunching up on itself, like what we had before, like I think last week, and that is a non-starter. Like that can't happen, because that just screws with the position of those strings essentially as it spins around. So that can't happen. We need the strings to coil in such a way that they don't interfere with each other and that they don't bunch up on each other. And I've got an idea of how this might work. If I just move this, I can move this camera and show you this little test rig that I've made. Let's go here. So here, let me zoom in a bit. I've got two strings, and they are set up so that when one coils on, the other one uncoils. And I probably should have used a different color string than black, because the black on black is a little bit hard to see, but hopefully you can see it well enough that they are kind of sharing this same middle space. So we won't need to make the spool too long to fit all four of these channels. And they do a decent job of like sticking in the grooves, but they do come out a little bit. And I have to be very careful with the way that I'm pulling this to make sure that they stay in. So I think something like this might work, and like it does a pretty good job when I'm going quickly. I think something like that might work, but I don't know. It's tricky. So yeah, this would involve 4 strings and not 2. And up until about 12 hours ago, I was leaning towards option 2, because it feels like having these strings be fixed onto that spool, like there's no way that they can slip then. They are on. But I don't like the spool. I don't want the spool to be too long. And even with this like sharing the same space sort of thing, the spool will still need to be a little bit longer than it currently is. And I don't like the idea of that, because it's going to pull weirdly on the motor. And also, I don't like that means that I'll need to be carefully paying attention to the diameter of the spool as it compares to the stroke length of the hand. Because if the stroke length is longer, more string is going to need to coil up on the spool versus if it's a shorter stroke length. And that's compared to the Capstan design, like as it is right now, there is only ever the same amount of string. Like there's only ever 2 loops on each of these. Like no matter where I position this, there's only 2 loops. And so I could make this stroke length like 50 meters and it doesn't matter. It's always going to be the same amount of string on here. And I really like that. It feels so much neater to me. Although actually now that I think about it, if it's too long with the Capstan design, then so you may notice that like as I move this, where the string wraps around the spool, that travels up and down. So actually now that I think about it, if the stroke length is too long, then that travel might get cumbersome in the same way that too many wraps would get cumbersome. It's so tricky. Yes, but I have some thoughts about this design in general anyway that I would like to unload on you. Which is that this setup with the strings being like 2 strings going up to the bottom of the hand and 2 strings going around and to the top of the hand, this is quite interesting, because when the hand is down the bottom, there is a huge opening in here that I can use to access the hand. And I'm thinking that this could actually be really convenient for loading Jugglebot up with another ball after it's thrown the first one. This is something that a lot of people have asked me about in person, where as soon as we start thinking about like multi-ball juggling, it's a very natural question for like, how do you start? Because as a human, when you're juggling, you can just hold multiple balls in your hand when you start and just release one at a time. But Jugglebot will not have the capability of doing that, and I don't anticipate ever giving it the capability of doing that because that's going to be a bit annoying to do. But what I'm thinking is that because this is so open on the side here, I could have the hand like go right down to the bottom and then have a little loading mechanism that just like shoots the ball up and gets it in there, and then it can go off and throw. And this would not have been possible before when I had 3 strings going up and down because there just wasn't enough space to get the ball in here. But like now there's this huge channel that I can like access through here. So I quite like that about this design, and it would be cool if we could keep that access because I think that will actually be super handy with loading this up. But we'll see. Yes. There's one final thing that I have to mention, which is that I'm going to change the way that these streams are run a little bit. After last week's stream was a whopping 4 hours, and I can fully appreciate that that's a little bit intimidating to click on and to commit to a 4-hour video, even though you don't, you can just exit out at any time, but I very much appreciate that. So what I'm thinking of doing is 4 weeks when I do like a working session, like I have been the last couple of weeks, I'm thinking of splitting this up into 2 streams. So that the first stream, the one that we're in now, will be like the update, and then there'll be a second stream that will start immediately after the update is finished, and that will be on the working session. So hopefully this should make it a bit easier for people watching these back later on, and you can go, oh, okay, cool, I want to see the update. Cool, I'll watch that. It'll be 20 to 40 minutes usually, I would guess. And then the working session might be an hour, might be a couple hours, and if you don't want to see that, you don't have to, and it just kind of hopefully delineates that a little bit more easily. So I'm a little bit hesitant about the fact that this is going to create more, I don't know, spam. I hesitate to call my own stuff spam, but I don't know, different strokes for different folks. So yeah, let me know what you think about this. This is the plan for this week, and yeah, we'll see how it goes. So that's about it for this week. I'm very, very torn about this design. My plan for the working session this week, up until last night, was to redesign this end part, the same one that we did last week, and redesign it with the intention of having all 4 strings terminate in the spool. But now I have some other ideas. One of them, I think we can get synchromesh working. My thinking is that if I line a spool with heat shrink and then have the heat gun pointed on the heat shrink and wrap the synchromesh cable around the heat shrink really tightly, we might be able to like mold the form of the coil around the synchromesh onto the heat shrink so that those grooves kind of stay in there. Maybe, I don't know. There is one more thing that I want to mention before ending this update stream, is that at the beginning of the working session stream that will start in a couple minutes, we have a special guest. We have John Benno, who has been working on his own hand mechanism and has some thoughts for me. We haven't spoken too much about specifically what he wants to mention, so this will be a new insight for hopefully most people. So if you want to see what John has to say, then hop into the start of the working session stream and we can see what he thinks. I have a feeling that his input might change some of the ideas that I have around this, so I really want to get his thoughts on this concept before committing to doing any CAD or anything. But yes, very, very up in the air right now, but it feels super close. This design, I'm really, really happy with it, except for the string slipping. If the string didn't slip, this would be perfect. This would be exactly what we need. Very close. Very, very, very close. But anyway, that's about it for the Oh, cool. I'm very keen to see your demo, John. Yep, cool. Update, done. You're all caught up. So I will start it might take a couple minutes, but I'll start the working session stream soon. So hang tight, and I'll hopefully see you soon. And if you're not hanging out for the working session stream, totally fair enough. And I wish you the best of luck with everything you're doing until next week. Bye-bye.